Okay guys, I'm going to do a short video on what this unit is all about. This unit is all about naming, and so there is a big note packet that gives you more information, but most everything that we've talked about can be summarized in this one short document, okay? So this is basically all of the unit that we're going through. So let's start with the top. So we're going to first go through ionic compounds. So we have ionic versus covalent. So when you're naming things, you're normally going from formula, oops, if I can spell formula correctly. You're normally going from the formula to the name. So this document is all about how to come up with the name, and then we'll talk about how to go from like the opposite direction in a second. So the first thing you need to determine is it ionic or is it covalent? So ionic means that it has to have a metal. And remember, metals are on the left side of the periodic table. And under this staircase is the metalloids. So most all of the elements on the periodic table are actually metals. So you have to determine, does it have a metal or does it not? If it has a metal, then you're going to name it according to the ionic rules. So you're basically just going to separate it out into two parts, the cation and the anion. So the cation will always come first every time, okay? So it will be the first thing that's written. So my example right here, I have CONO3, 2, okay? Let me put an easier example for you though. Let's change out our metal. You'll understand in a second. Okay, this is an example as well. So you have to look at the cation. The cation will always come first. So this is your cation, okay, because it's the first thing. So for cations, you have to ask yourself, is it transition metal or is it not, okay? So magnesium is on group 2 on the periodic table, so that means that it is not a transition metal. If it is not, you're just going to name it. So Mg is magnesium. Okay. If it is a transition metal, so let's look at an example over here. Let's look at this one. CONO3, 2. Cobalt is the metal because cobalt is on to the left of the period of the staircase. So cobalt's a metal and it is on group, hold on. I don't know, it's in the D block. So if it's in the D block, that means that it is a transition metal. Okay, if it is a transition metal, we have a few steps. We have to look at the formula, this is the formula, to find the charge of the metal. Okay, so to do that, you have to look at the anion. The anion is the second part. So we are going to look at this part right here and say, what is it and what is its charge? Well, NO3 is nitrate. It's a polyatomic ion. And so NO3 has a -1 charge because on your polyatomic ion list, that's just what it has. It's a -1 charge. Well, I have 2 of them. Do you see this 2 right here? I have 2 NO3s. So if I have 2 of these, that means that I have a total of -2 charge. Okay, because let me draw it out for you. NO3 -1, NO3 -1. If this is what I have, do you see how I have a -1 and a -1? So they're going to add up to make a -2. So this entire negative part right here has a -2 charge. Okay, well, the cobalt comes first, so it's going to have a positive charge. And since your negative side is -2, it has to balance that out. So your cobalt will end up having a +2 charge, okay? So the only reason that we had to determine the charge is because we're working with a transition metal, so we have to find the charge. Once you find the charge of cobalt, you're going to put the charge in Roman numerals, in parentheses, okay? So let me erase some of this so I can have room to write. Okay, so we determined that cobalt has a +2 charge. So we're going to open parentheses and put that in Roman numerals in the parentheses. Okay, so that is referring to the charge on cobalt. Okay, the reason that we had to do the charge is because we're dealing with a transition metal. Transition metals, we can't just look at their group number like we could with magnesium and determine the charge. So you have to come up with the charge, okay? So for magnesium, you did not have a transition metal, so you just name it magnesium. For cobalt over here, you did have, cobalt is in the D block, so it is a transition metal. So you have to find the charge on your anion. So NO3 had a -1 charge, but there were 2 of them, so that made a total of -2. That means the cobalt has to have a +2 so that you can balance it out. So once you find the charge, you then put it in as Roman numerals in parentheses, like this. Okay, so once you're done with the cation, okay, you're going to move on to the anion. The anion is always your second thing, okay? Okay, so you can have a monoatomic or a polyatomic anion. Let me show you the difference. Let's work with magnesium again, Mg, and then if I put Cl2 versus MgNO3 we are looking at the difference between monoatomic and polyatomic. So monoatomic means 1, mono means 1. So if you cover up the magnesium, all that's left is just Cl, okay? That is one type of element. Polyatomic means more than 1. So if you cover up the magnesium and look at everything that's left, you have NO3. NO3 is a polyatomic ion. It has more than one type of atom. So polyatomics, you just name what it is. So NO3 is nitrate. You can know this by looking at your yellow polyatomic list under your desk, okay? Or in the PowerPoint that I have, there's a list for them as well, okay? So polyatomics, you just name it. So if I'm gonna name magnesium nitrate, magnesium and nitrate, I just put it together. Okay, so what about this one right here? I have Mg and I have Cl2. So Mg is, I'm going to erase some of this. Mg is magnesium. We figured that out earlier. Cl is chlorine. But since Cl is monoatomic, we have to change the ending of chlorine to -ide. So I am going to change the ending right here to IDE. So instead of chlorine, it's going to end up being chloride. So MgCl2 is chloride. Let's practice some. Let's look back at this one. Okay, so we determined earlier that this is cobalt, and that cobalt is a transition metal, so I have to determine the charge on it. So I'm going to look at my charge of the anion. This is a -1, but I have 2 of them, so that makes a -2. So that means that this side has to be +2 so that these can balance. So back in my naming, I'm going to name this cobalt 2 for the charge. Then I just name my anion right here. NO3 is a polyatomic. It is called nitrate, so I just name it nitrate. Okay, what if we add this? All right, well, CO again is cobalt, and it's a transition metal, so I don't know the charge. I do know it's positive. So I have to look at my anion. My anion is chlorine. Well, chlorine is on group 17. Well, all of group 17 has a -1 charge, okay? Because group 17, remember the whole goal is to get to 18, to get 8 out of 8. 8 out of 8 valence electrons. Well, group 17 has 7 out of 8. So how do I get there? I gain 1 electron. And if I gain an electron, that gives me a negative charge. So all of group 17 has a -1 charge. So this chlorine has a -1 charge. But there are 3 of them. So 3 chlorines with a -1 charge means that I have an overall of -3. Well, the positive charge has to balance that out. So I have one cobalt with a positive what charge? Well, it has to be 3 so that these can equal. So the cobalt will have a positive 3 charge. Okay, so then we just continue with what's next. Cl is chlorine. Okay, chlorine is a monoatomic, so we have to change the ending. So we can't ever write chlorine or we can't ever write oxygen at the end. You always have to change it to IDE. So CoCl3 is cobalt 3 chloride. Okay, let's do one more. Let's do this one. So I think that I wrote it up here, maybe not. Okay, yeah, right here. If you notice, it says transition metal, or post-transition metal, okay? So transition metal or post-transition metal, you have to find the charge of it. So Pb is lead. Lead is directly under the staircase, so it is a post-transition metal. So I have to figure out what the charge is. This is charge. Okay? So to do that, I go back up to my problem and I look at the anion, which is whatever is second. Well, O is oxygen. Okay? Oxygen is on group 16. Oops. Okay? Remember, the whole goal is to be like group 18. Okay? So group 16 has 6 out of 8 valence. How do I get 8 out of 8? I'm going to gain 2. So that would give group 16 a -2 charge. So each of the oxygens have a -2 charge, but there are 2 of them. So, oops. 2 times 2 gives me an overall of -4, okay? Because I have 2 oxygens with a -2 charge, so I have a -4 charge. So my lead has to be +4 so that it can balance out the -4. So the charge on lead is 4, okay? Then you just name whatever is left with it, which is O, and O is oxygen. Remember, we changed the ending to IDE if it's just like a normal element, like oxygen. So it's going to be lead 4 oxide. Okay, now all of these right here, all of these have been ionic. Now we need to look at covalent, okay? So for covalent, you have to only have nonmetals. You cannot have a metal. Okay, and for covalent, there are 2 options. You have acids and you have anything else. So acids have to have an H in front. If it does not have an H in front, then it is not an acid. If it is not an acid, then you will name it using prefixes. So let's look at all of our prefixes. A prefix is something that goes in front of a word, okay? So for covalent, not acids, okay, we use prefixes. So for 1 atom, the prefix is mono. For 2, it's di. 3, tri. And these are prefixes, so I'm going to put a dash, meaning this goes in front of whatever the word is. For 4, it's tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. 10, deca. Okay, so however many of the atoms you have, you will use one of these prefixes. Your only exception is right here. You never put mono on the first element, okay? And then the only other thing you do for not acid covalent bonds is you change the ending of the second element to IDE. So let's practice. If I have SO2, okay, the first thing you check is it ionic or covalent? Well, is there a metal? S is a nonmetal, O is a nonmetal, so this is covalent. Then you check acid or not. Well, acids have H in front. Is there an H in front? No, there's not. So that means that this would be not an acid, okay? So for not acids, the first thing you're going to do is just name the two elements. S is sulfur, O is oxygen. But remember that on the second element, we changed the ending to IDE. So it's going to end up being oxide, okay? The next thing you do is you put prefixes. So I have 1 sulfur and I have 2 oxygens. So 1 sulfur means that I should put mono right here. But the rule is that you never put mono in front. So I can't put mono in front. Now I can look at the oxygen and say I have 2. So this is di. So the name of this is sulfur dioxide. Okay, let's do another one. N2O. Again, ask yourself all these questions. Ionic or covalent? It's covalent because I don't have a metal. Acid or not? It's not because there's not an H in front. So it is not an acid. So that means that we just name our two pieces, change the ending of the second element. So N is nitrogen, O is oxygen, change to oxide. Okay. Now we look at how many we have. I have 2 nitrogen, so I'm going to put a di in front. I have 1 oxygen, so I'm going to put a mon for mono in front. So you do put mono on the second element, you just never put it here, okay? All right, this is about as easy as it gets when it comes to naming. You just name the 2 parts and then put the prefixes. All right, the harder kind of covalent is acids. So acids have an H in front, and you have 2 options. You have a binary and an oxyacid. An oxyacid will always have oxygen accompanied by some other element. And both of these options will have an H in front, okay? So binary is a mono acid because this element, whatever it is only one type, okay? Oxy is a poly because whatever is right here has oxygen and something else. So this would be 2 types. You name them differently. For the mono ones, you will start the name out with a hydro. You will end the name with ic every time. For the polys, for the poly one, you will not put hydro in front. Do not put hydro in front. The only thing that you will change is the ending. So if your polyatomic ends in 8, you will change it to ic. For example, NO3. Okay? NO3 is poly. It's nitrate. I'm going to change the 8 to ic. So I'm going to end up with nitric, and then I'm just going to put acid after the name. Okay? Here's another example, NO2. So if your polyatomic ends in ite, you will change it to OUS. So NO2 is nitrite, so that's going to change to nitrous. Okay, so let's do some examples on this. Let's do HCl. So the first thing you ask yourself, is it ionic, is it covalent? Well, both of these are nonmetals, so it's covalent. Is it an acid or is it not? Well, H is in front, so it is an acid. So put acid at the end of the name. Then you have to ask yourself, mono or poly? Okay, well, to do that, you have to look at the second part of the word. Is this one type of element or does it have 2 types? Well, Cl is just chlorine, so this would be mono. If it is mono, you're going to put hydro in front of the word and you're going to put ic at the bottom. In the middle, you put whatever this is, which is chlorine. So this is going to be hydrochloric acid, okay? Let's do another one. HF. Ask yourself ionic or covalent. It's covalent because only nonmetals. Acid or not. It's an acid because you have an H in front. Okay, then you have to say, look after the H. Is F mono or poly? Well, F is one thing, so it's mono. If it's mono, you're going to put hydro in front. So you're going to end up with hydro, fluor for fluorine, fluoric acid. Okay, now I'm going to do another one right beside the hydrochloric so that you can see the difference. HClO3. Okay, so is it ionic? Is it covalent? Well, everything is nonmetals, so that has to be covalent. Is it an acid or not? Well, it has an H, so it's an acid. Okay, so then you look after it, and you have ClO3, mono, poly. Well, you have Cl and O, so that means that you have more than one type. So for poly, you do not put hydro. Okay, so do not start the word with hydro. You just ask yourself, what is ClO3? Well, it is chlorate. So 8's changed to ic, so this will be chloric acid. Okay, let's do another one. Let's do HClO2. Okay, it's an acid because it has H in front, because it's all nonmetals. So then we have to look at the second part, ClO. ClO2 is poly because you have more than one. You have Cl and you have O. For poly, you're just going to say, what is it? ClO2 is chlorite. Okay? Change ite to OUS. So we're going to get chlorous acid. Okay, so that is all the rules. That's everything we've learned. The only thing that we need to cover now is how to go the opposite direction. How do we go from name back to formula? Okay, I'm going to do one with a transition metal because those are the trickiest ones. So let's do iron 3 chloride. So you just start from the top. Iron is Fe, okay? What's after iron? This 3. This 3 is the charge. So you're just going to put a +3 charge on iron. Next, chloride. Well, chloride, ide comes from the periodic table. So what is chlor? Chlor is chlorine, and chlorine has a -1 because it's on group 7. Okay. The last thing you need to do is make your charges balance. Okay? To make your charges balance, you're going to take the charges and do a lasso effect. So what I'm going to do is take this 3 on iron and put it to the bottom of chlorine, and take the absolute value of the 1 and put it on the bottom of iron. So then you get FeCl3. And this works because I have Fe with the +3, and I have chlorine, but I have 3 of them, and each of them have a -1. So then I have a +3 balancing with 1, 2, 3 -1s. So the charges balance, okay? This lasso thing will work every single time. Let's do an acid one. Okay, so the acid means that you're going to automatically put an H+ in front of the formula. Then you have to look at the actual word. Remember, hydro means you came from mono, and mono means it's from the periodic table. So, what is phosphor off the periodic table? Well, that's P for phosphorus, so I'm going to put a P. And then phosphorus is on group 15, so it gets a -3. Because group 15 has 5 out of 8 valence, how do I get to 8 out of 8? like gain 3, so that would give me a -3 charge. So the last thing you have to do is balance the charges. So the way you do that is you do your lasso effect. So we're going to end up with H with a 3 at bottom and P with an understood 1. So that's your answer. Okay, this just takes a lot of practice, so I'm going to fill out your note packet and put it online so that you can see some more practice.